Hello, this is help for homework number 5. So here we go. Homework number 5, there are 10 problems. And let me go first for the problem number 1. Problem number 1 is about these objects in contact. And we did this in detail in lecture for a number of cards that, let's say, you are pulling with a given force, and in this particular case there is no friction, and in the case of problem number 1 you have more cards than what I'm enumerating here. But what is important is the following. For example, if you want to calculate the tension here, the tension here of course is equal and opposite to the one that pulls this one and it pulls back on this one. And this one, this force here, this tension here is equal to this total mass times the acceleration. So what you have, and this force here, this tension here, is this mass times the acceleration. So from the information that you have, you just have to know exactly where they want you to calculate the coupling tension, and the information given is such that you can calculate the acceleration. Number 2 is a problem about friction, and this is the case of, first of all, the case of the horizontal object. The horizontal object, you have to pull an object or push on an object in order to set it in motion. And if you pull on an object with a force F and the object does not move, it means that that force is less than the coefficient of static friction times the normal. And when you are in an horizontal situation, the normal force is equal to the weight. So this is less than that. But when it just starts to move, then these become an equal sign. So the force when you just start to move is equal to the coefficient of static frictions times the weight, and this information is given. Once the object moves, then you need less force to make it to accelerate, and the net force when it's moving, the net force is the force with which you got it to move minus the kinetic friction. So if you keep pulling with this force, then the net force now is going to be the difference between these two. If I go to problem number 3 and problem number 4, these problems were done in detail on Wednesday lecture. The identical problem, I first did the case of, in lecture, of the case of two masses with one in an horizontal and the other hanging, and with no friction. We did that problem in detail. So of course, if there is an acceleration in that direction, there's going to be an acceleration in this direction here, and it's the same. Once you have the acceleration, of course, and if that acceleration is constant, then you can calculate the velocity of the object at any time, or you can calculate the displacement of the object at any time, given the information that you have. So that should be straightforward. And the same happened from problem number 4, which is the Atwood machine, and this was done in lecture. So you just have to look at the notes there. We actually in class we did it precisely like that. We took this positive and this positive, and we solved those equations. So now you just have numbers. So let me go to number 5. Problem number 5 is again a problem of friction, and is again the fact that the force of a static, the force that you try to pull to get an object to get moving, the force of friction is always equal to the coefficient of static friction times the normal force. So if you apply a force of this magnitude, it means that, and it's refused to move, it means that the coefficient of static friction is greater than that force divided by the normal force. And again, the force that you just needed to slide correspond to this value. And if you need less force to have any motion, then you can calculate the coefficient of kinetic friction.